All right, let's solve a puzzle that is quite literally a matter of life and death. The science of blood transfusions. You see, if you get it right, it's a miracle. But if you get it wrong, well, it can be fatal. So what's the secret?
It's a pretty wild paradox when you think about it, right? The exact same procedure can be a total game changer or a fatal mistake. And the difference? It all comes down to one simple word: compatibility. An incompatible transfusion kicks off this violent immune reaction, causing the blood to clump together in a really dangerous way. That's called agglutination. So what is this hidden biological code that decides who can safely share blood with whom?
So, our first clue to cracking this puzzle is to understand what blood is actually made of, because it's a lot more than just a simple red liquid.
When you picture blood, don't just think of a liquid. Think of it more like a complex suspension, almost like a biological soup. About 55% of it is the broth, this yellowish liquid called plasma. And the other 45%? That's all the solid stuff, the cellular elements, just floating around in there.
Now that plasma broth is mostly water, but it's also packed with all sorts of important proteins. And in the cellular part, you've got white blood cells for fighting infection and platelets for clotting. But the real star of our show, the key to this whole puzzle, is the red blood cell. These are the guys that carry oxygen, and they hold the secret to transfusion compatibility.
Okay, so how does your body know which blood is friend and which is foe, which to accept and which to reject? Well, here's a great way to think about it. Picture your entire circulatory system as this super high-tech, secure building with a very, very strict security protocol.
Every single one of your red blood cells has a special protein on its surface, and it's called an antigen. The best way to think about this is to just picture it as the cell's official ID badge. It basically screams, "Hey, I belong here. I'm one of the good guys." And, patrolling the hallways of this building, just floating around in your blood plasma, are the antibodies. These guys are your body's security guards. Their entire job, day in and day out, is to check the ID badges of every single cell they bump into. And if they find a badge that doesn't match, they sound the alarm. So, you get the picture, right? You've got the ID badge, that's the antigen, stuck on the cell. And you've got the security guard, the antibody, patrolling the plasma. Your body's whole security system is designed so that your guards recognize your own cell's ID badges and just let them pass. The trouble only starts the moment a cell shows up with an ID badge they don't recognize.
Okay, so how does this whole security system thing connect to the blood types we hear about all the time? A, B, and O. Well, it's actually pretty simple. Those letters are literally the names printed on the ID badges.
This table really breaks it all down. So if you have type A blood, your cells are wearing A ID badges. That means your body makes anti-B security guards to attack any B cells that show up. For type B, it's just the opposite. Now look at type AB. It has both A and B badges, so it can't have any security guards, otherwise it'd attack itself. And type O, it has no A or B badges at all, so its plasma is full of both anti-A and anti-B guards. The plus or minus part is just a separate ID system called the RH factor. Positive means you have that ID, negative means you don't. Okay, knowing what we know now about this whole security system, you can probably figure this one out. Which blood type can be safely given to pretty much anyone? Yep, in pretty much every emergency room in the world, the answer is O negative. So why is O negative the hero here? Well, it's because its red blood cells are like these little stealth agents. They have a totally blank identity badge. No A antigen, no B antigen, and, this is the important part, because they're negative, they don't have the RH antigen either. These cells can slip right past any immune system security guards without setting off a single alarm. All right, so if O negative is the ultimate giver, who's the ultimate receiver? Which blood type can safely take blood from pretty much anyone? That distinction goes to AB positive. So what makes an AB positive person the universal recipient? It's because their body is just super welcoming. Their plasma has no security guards at all, no anti-A and no anti-B antibodies. So when red blood cells from another type come in, there are literally no guards there to attack them. Okay, but in a real hospital, doctors obviously aren't just guessing based on these rules. They have a super strict protocol to make sure every single transfusion is a perfect life-saving match. It's basically a 3-step safety check, and it's absolutely critical. First up is forward grouping, where they figure out what ID badges are on the patient's cells. Second, they do what's called reverse grouping, and that's where they check for which security guards are on patrol in the plasma.
And finally, for the ultimate safety net, they do a cross-match. It's like a mini transfusion in a test tube, mixing donor and recipient blood just to see for themselves if there's any trouble. You see, it all comes down to one golden rule, the absolute key to everything we've talked about. The donor's ID badges, their antigens, cannot, under any circumstances, trigger a reaction from the recipient's security guards, their antibodies. Is really that simple and that critical.
Every single thing we've discussed, from the ID badges to the security guards to all those lab tests, it's all designed for one single purpose: to avoid agglutination. That's that dangerous clumping of red blood cells that happens when the security system goes on the attack, and it's exactly what makes an incompatible transfusion so deadly. So, at the end of the day, what looks like a simple medical procedure is actually this incredible dance, successfully navigating a really complex, high-stakes security system at a molecular level. Understanding the roles of antigens and antibodies is what turns this whole thing from a deadly gamble into one of the greatest miracles of modern medicine.
You know, we've basically cracked the code for matching human blood, which is just an incredible achievement. But it makes you wonder, what's next? The next big frontier? Maybe creating a truly universal artificial blood that makes all this matching stuff obsolete. I mean, imagine a world where your blood type just doesn't matter at all. Now, that's really something to think about.